Good day to Dr. Roslanini. We are students from Group 13 to present the activity to rerun the video. First of all, we will install the packages needed and call the packages which are T-Series, Forecast, and ReadXL. After that, we import our downloaded datasets from our laptop, and the CPI variable is the dataset. Then, we input this code to check the structure to ensure all the data is correct. First stage of model identification, we need to plot the original series. We input this code containing TS function to define all the variables such as CPI value, start and end period of series, and frequency equals to 1 to represent the yearly dataset. Next, we will plot the original series and the plot of our CPI data is shown on the right-hand side. Based on the CPI data plot, there is a significant upward trend from 1972 until 1997. This is a sign that the series is not stationary since there is a trend component in this series. Next, for Box-Jenkins methodology, we plot the SCF and PSCF for the original series. Based on autocorrelation function SCF for the original series, the SCF is slowly declining as the number of lags increase, suggesting that the original series is not stationary. The term slowly decaying can also be used to explain this pattern. In addition, based on partial autocorrelation function PSCF of the original series, there is one significant spike. This is a signal that we can perform the first differencing to turn the original series into stationary series. So based on the SCF of the first difference, the rate of decay is much faster, which the changes from positive autocorrelation at lag 5. Meanwhile, for PSCF, it shows significant spike at lag 1 and lag 8. Then, we proceed to the second stage, which is model validation and estimation, whereby we may decide to order of our ARIMA model. For example, we choose ARIMA 313 as model 1. And all the readings of autoregressive AR and moving average MA are shown. Besides, it is also shown the AIC values. Then, we repeat the same steps for ARIMA 310 as model 2, ARIMA 111 as model 3, and ARIMA 110 as model 4. Due to model for ARIMA 110 giving the lowest AIC value, we choose model 4 of ARIMA 110 as the best model. After that, we input box text and based on June box test, we accepted the null hypothesis indicate that the residuals are white noise. The third stage is we proceed with the application of ARIMA 110 to generate 5 years ahead forecast values by inserting this code. So for further investigation, we will input this. Therefore, the forecast values for 1998 until 2002 are 112.39, 114.52, 116.34, 117.91, and 119.25. So for the last step, to test for stationary, we input ADF.test and call for the TS data. And the hypothesis shown is stationary. So that's all for our presentation. Thank you.